Hi class, it's just a clarification video. I didn't want to reshoot the whole other video, but just to update this this slide. And so with the current course, so working with mutually exclusive, non-mutually exclusive events. So the idea that two things can happen at once, and Einstein's got a good quote here to reflect that. So in the other video, it didn't say it like this, but here the learning goal, we're learning how to display non-mutually exclusive events, so things where there is overlap. But we're going to learn about displaying both of those. We're going to differentiate between mutually exclusive, non-mutually exclusive, and use probability notation. Just to clarify some definitions, and so these are the definitions of mutually exclusive, so things that can't happen at the same time, like right and left turns, even odd numbers on a die, winning and losing a game. And then mutually exclusive things are things that can happen at the same time, so things like driving, listening to the radio, that kind of thing. Okay, now just to kind of help with these questions here, some things that I tell my students in class. With the first one, we realize that there are two sets to both of these questions, and so we realize it's basketball and volleyball, and so the chances are like she can make both. We notice that these numbers here, they're all like different fractions and different denominators. If you make them all the same, or you count them percentages, that's probably how I would deal with a question like this. And so you can kind of put your 50% right in the middle here, and then work with it that way. The second question is a little bit more challenging because of the fact that you don't have the overlap. So you have to figure out what that overlap is. Now, one of the ways you can figure that out is using that formula, N of A union B, N of A union B, so A and B together, A would be like headaches and B would be cold, equals N of A, which you have, plus N of B, which you have, minus the intersection of N of A intersect B. And so if you're looking at the solution, you can see how this formula could work, because we actually know N of A union B. We know what the numbers have to add up to inside the three elements. And so by three elements, I mean there's going to be four numbers inside the Venn diagram. If you're looking at the solution, you can see how we got these numbers. So these four numbers have to add up to 100%. The 32% is the challenge. Like, how do you figure that out? And the formula will help you find that out. You can also make it work so that, say, you know that these have to be, say, 60%, and then these have to be, say, 48%. I use percentages here. You can use the total number of people. It doesn't really matter.